So today I'm going to review this thing. This is a LCR tweezer from Zoyi Zotek. This has been sent to me at no cost for the purpose of review. If I remember rightly, I've already reviewed one of their tweezer meters before. I've done a Finersi one and also got a Shannon tweezer. I've got a couple of them anyway. But this is a new one. This is the MD2 ZT-MD2. It's got higher frequency, it's got some extra features on it. Nice little case. We've got a little test board here. I guess this might be used for calibration, I'm not even sure. But it's got a bunch of resistors on there. Got a USB cable in there. And also the tester itself, which sits in there quite nicely. If anything, it might sit in there a little bit too well. Looking at the sizing. Yeah, the actual tips going into the foam there. So, you don't end up digging in. Let's look at the manual. Here it is. It's very, very small text. Can you read that? Inductance, capacitance, resistance, voltage will obviously be limited. It's got secondary functions. Phase angle is an interesting one. It's not always there. So the specifications, what you expect to see out of it. Wish the text didn't wrap around. Just messing with my topography skills. But one of the things you may notice here, it's got 0.1 volts, 0.3 volts and 0.6 volt signal levels, which is great. It means you can set a low voltage and avoid triggering silicon junctions and stuff like that. And then frequencies, 100 Hz, 120, 1 kHz, 10 kHz and 100 kHz. 100 kHz in a tweezer, that's quite nice. Yeah, obviously that's a bit of a giveaway because it's in the column here as well. But you can see the error ratios here. Best is 1 kHz, lowest error and resistance, capacitance. But you can see that this shows the larger the capacitance, the lower the frequency should be. The smaller the inductance, the higher the frequency you should use for testing that. General technical information just there. Calibration 0 ohms to the 10 mega ohms and an open, which I'm guessing that is what that board there is intended for, because that's got those 0 ohms to the 10 mega ohm resistors on it. So it's probably meant for calibrating it. So it's nice they actually included that with it. Although I think it might be an option, and it depends which package you get, I think. And how to use the thing. And the other side tells you the buttons, what they do. So it's got zeroing on it as well. So if you do a long press of button number 2, which is the second one over, that will do zeroing. So you can do offsets. Okay. So for 4-button interface, it actually does quite a lot. It's quite good. What's the maximum voltage it can go up to? Forward voltage reading diodes is up to 0.9 volts for diodes. That means you won't be able to do LEDs, right? It's got a signal generator. Yes, it's got a signal generator. It's also generating waveforms anyway to do the LCR it's testing, so they've added that as an option to generate waveforms up to 100 kHz. Anyway, tells you how to use that as well. Film upgrading, of course. So 16 volts maximum, plus or minus 16 volts max. So that's the most you can do on the voltage test thing. So it's alright if you're doing some in-circuit stuff on something you know doesn't have anything more than say 15 volt rails, then you can quickly use that to test those. A bit dangerous, but nice it does it. Now I have various standards and stuff here, which I'm going to test this on and see how it comes out. This actually has a film on the screen. Let's get this off, shall we? Might make it easier to see. As I mentioned in the mailbag, I was quite impressed by what I saw on it when I did have a quick look at it. This has got a metal housing on it. Anodized aluminium housing. Metal. Nice. You might even take it apart and have a look at it. Gold plated tips. Also nice. They touch together nicely. In the hand, feels good. Feels weighted about right because it's sitting right here, so the length seems about right for in-circuit testing or what have you. So that seems like it's going to be really good for that. Just power it on. Look at the screen, let's get a close look. So one of the things that surprised me when I was messing around with this thing when I was looking at this in the mailbag, when I rotate it over, the display changes. So it's got automatic deselection. So if you're left-handed or right-handed, doesn't matter. You rotate it around, the screen changes. Or if you're rolling your hand around where you're doing testing, it automatically changes, which is a really nice feature. Let's just push some buttons. So this one here, frequency. Hold it down, it goes into menus. Let's go down. There we go, down direction. You can also fix it to a certain orientation as well if you don't want it to be automatic. Backlight brightness, I'm going to leave it turned up right for now. Volume of the beeper, this does a little beeper so you can confirm button presses. I quite like that actually. I know some people don't like beepers or having little beeps and stuff each time you push a button. Well, I quite like having a beep because it confirms that the unit has seen the button push. Timer versus, I'm guessing it's auto off. Speed, so this must be default settings from turn on, because you can manually set the speed as well. Model, series, auto and parallel. This would be for like testing capacitors maybe. Parameters, automatic parameters for the second function. Functions available, so you can go in here I think and turn off things you don't want to use. So if you're not using the signal generator for example, I think you can go in and turn it off. So I go in there, push that, there you go, disabled it. So I'll tell you if I've gone again for now. But yeah, so if there's certain functions you don't want this thing to actually be doing, because you want to skip through the modes very quickly, then you can turn off the things you're not going to be using. That's quite nice. Calibration, so on-screen calibration guide. I'm not going to do this, I'm going to use it as supplied. I'm not going to do a calibration on it. I'm going to use it exactly as supplied by the factory. Restore, so I guess that's like a factory reset, and there's the bout. So it's version 1.2.2. That's the current firmware version as supplied. Again, I'm going to test it as supplied. There may be a newer firmware version by now by the time you see this video, or in the future when you see this video. But as it is, I'm going to leave it like that. So that's that button. Next button, changes voltage. Do you like the fact that the button's directly above the thing you're trying to change? So it's nice and obvious. Okay, so there's our 3 voltage levels, and hold it down, and that's the speeds. So slow, medium, fast. Modes, so you've got resistance, capacitance, inductance, diode test, voltage. Though here it says plus or minus 32 volts. In the manual it said 16 volts. Interesting. Is that something I managed to improve? That makes it much more usable actually, and a bit safer. And this one I found quite interesting. Scan. Look what it's doing. It's switching frequencies and doing a test, and switching to the next frequency, doing another test. So if I hook this up to something, this is just to go to like a 10 mega ohm resistor, just for simplicity for now, and it will step through each one, and you see how it performs at each frequency. So you can see how it's affecting it. So if you're doing inductance, for example, testing inductors or capacitors, this could be really useful for you. You can just do a scan one and you can see how it's going to perform at each frequency. So that's nice. But it seems to mostly be showing resistances. I don't know if it shows capacitance as well. And there's a signal generator function. Oh, there we go. So frequency, amplitude, they're 3 volts. Interesting. PWM, triangle wave, different waveforms. Wow. Bit more than I was expecting actually. I wasn't expecting yeah, so sine wave, PWM, triangle wave, trapezoid, half wave, full wave. So that's for simulating going through a diode bridge. And noise. Nice. I'm actually really surprised by that. Change of the functions. So 10 Hertz. 10 Hertz. There you go. So you can go as low as 10 Hertz. Just want to see what it goes up to. There you go, 100 kilohertz as expected. Right. Nice. Okay, well, that's the screen. Let's actually do some tests on it. So, I've got my decade inductor here. This can go up to like 11 henries or something. Currently going 1 millihenry. Using 100 Hertz. Suppose I could change the frequency. See what we're getting. So 1 kilohertz might be better. There we go, slightly better. So there's 2 for example. Now again, frequency is an issue on this, alright? So Obviously in this orientation it's kind of back to front, so opposite corner. So if you are using it left-handed, you're going to have to get used to that, I suppose. 10 kHz is showing better. 100 kHz, way off. So 100 Hz is reading low. 120 is low. 1K is looking closer. So 1K might be the best one to use at that kind of value. 50 millihenries, that's looking pretty good. 100, yeah, not bad. Let's change frequencies again. 10K is reading high. 100K is way off. 100 Hertz. 100 Hertz is looking close, but still a bit low. 120 is looking very off. It could also be picking up mains interference here. 1K is looking pretty close. 500 millihenries, that's looking really good. 1 Henry basically. Yep. 5 Henries. Yep. And 10 Henries. Yep. It's certainly close enough. You know, it's not far off at all. And again, frequency dependent, that's the other thing, you know. So 100 Hertz at this is a bit noisy. Let's get out of the mains noise. So that's the decade inductor. Let's try something else. So now I've got a decade resistor here. It's my general radio one. Very good resistor, this thing. Did a video refurbishing this thing, so it's very good. So I've got it set to 0 ohms right now. Let's do 1 ohm. Yep, that's not bad. Let's just try and get a bit of connection down here. Yep, see it's dropping down. That's looking very good actually. That's at 1 kHz. Let's change frequencies. 10K, 100K, 100 ohms. This is probably going to get up mains noise, which might actually make it worse. 120 probably fluctuating range noise. 1K is probably the most stable to use. So that's looking really good. So let's do 10 ohms. Bang on. 100 ohms. Really close. 1K. Basically bang on. 10K. It's bang on. 100K. Looking really good. Let's go up to 1 meg. Yep. Looking pretty good too still. But yeah, okay, that's working. So I've got this capacitance unit here, decade capacitor. This is like picofarads up to 10 microfarad on this thing. I'm not sure the accuracy on this thing actually. I really should check this and see what actually it's doing. I don't remember offhand what it actually is. Anyway, at 0 we're seeing 53 picofarad. Let's try and null that capacitance out. Doesn't seem to do it. It's not nulling out. If I go manual capacitance. Okay, well it said it did tearing, but that's not tearing that value off. So that's interesting. So that's what we're getting, 53 picofarads, deduct that from the measurements we get. So let's do 100 picofarad, so I should get 153 or so. Yep, that's good. 1 nanofarad, yep, 50 or so from that. 10 nanofarad, yep, that's looking there. Again, still got that 50 to take off that. 100 picofarad, got a slight error there. Let's just try 200. 500. Yeah, okay. 1 microfarad. I'm measuring at 1 kilohertz as well, by the way. So that's moving slightly high there. So you say 5. Yep. And 10 microfarad. Looking not too bad. Changes ranges. It's probably why it shifts. So that's 9. That's 10. It's kind of getting there. It's interesting. I got 10 the first time. The second time I didn't. Let's go back up. Now I got it again. Okay. Maybe the switch is a bit dirty in us. Let's actually put this on a standard capacitor, which I know what the value is, and back down to 1. So we're reading 27 counts high on this. I'll do have 1 microfarad standard cap. Get that out. See some standard caps. 200 picofarad, 1 nanofarad, 20 nanofarad, 1 microfarad. Let's see what we get. Still 1 kilohertz. 200 picofarad, look at that. Basically bang on, that's good. 1 nanofarad. Not bad. Fraction high there, but that's a 1 kilohertz, don't forget. 20 nanofarad. Basically bang on. And 1 microfarad. Bang on. Can't argue with that. So let's actually use it to test its own resistors. This resistance standard thing that comes with it. Don't forget to click like and subscribe. And also, if you found my videos interesting, or you find this video interesting, you can support my Patreon. There's a link down below in the description for that if you want to support Patreon and become a channel supporter. Or you can buy me a coffee. One-off thing. You can also do that down below in the description there if you want to buy me a coffee. Right. So on capacitance, so I need to take it off capacitance for a start. Haven't checked diode mode out yet. Back to auto mode. So, got 0 ohms. It's basically there. 1 ohm. Yep. Looking good. 10 ohms. Looking pretty good. 100 ohms. Yep. Temperature in here right now is 26 degrees. 1K is looking really good. 10K is bang on. 100K. Need a little bit down. 1 meg, bang on. And 10 meg, bang on. But then it could have been calibrated with this thing, so, you know, that's probably why it's reading well. You just don't know. Okay, let's look at some other stuff. Let's look at a larger capacitor. This is a 1000 microfarad. Let's see what it thinks of this. Yep, not bad. Looks about right. You don't know exactly what the values are. Let's try a 10,000. It's reading somewhat high. I'm at 1 kilohertz though, so let's change frequencies. Okay, 1 hertz, looking much better. Might just change the voltage level, that might help. Bit noisy. Maybe I should do a slow measurement rather than a fast one. I have to hold down to change speeds. Do a medium measurement, let's do medium speed. Yeah, okay, I mean it's roundabouts. And a 15,000. And it's not identifying as a capacitor. Let's manually do this one. It keeps slipping off. Now do it manually, it's showing up just fine. Let's try a different voltage again. There you go. High voltage is working better for that. But yeah, okay, it's looking ballpark right. That's good. Let's try a tantalum. I haven't really tried tantalum capacitors. I'm doing testing. So here's a 4.7 tantalum. .7, nice. So I thought I'd just do something a bit more interesting. Well, a bit different. I bet it's interesting or not, but I don't know if it's more interesting. Anyway, diode mode. Got a random transistor here, so 2SA1012, just one I happen to grab. Let's just see if we can get diode junctions off this thing. Nope. That way? Yep, there we go, getting diode junction that way. Across those two, diode junction that way. Great. So that's actually working. And I think it's also giving polarity. See the diode symbol there? It's a bit dim, but it's not obvious. I don't know if it's actually giving polarity or not. Let's flip it around, see if it changes. It does. So there's a diode symbol here. So Zotek, hopefully you're watching this, that symbol needs to be made much brighter. You barely see it. And the brightness on this is turned right up. So that diode symbol needs to be made much more obvious. It's currently really grey and barely visible. It's nice it's there, so you can see polarities, but it needs to be improved. Anyway, that's good. Actually, just out of interest, I'm going to see if it will light up an LED or not. Okay, if I touch the tips together, it beeps. Nice. I didn't notice it did that. So if you've got a shorter diode, it'll tell you as well. This isn't lighting it up, not that I can see. It's also not returning as a diode, so I can't see this one, but it's an LED, so it's not really meant for that. I'll go and get a like a red or something. Right, some more LEDs. Let's pick one out. Yellow. No signs of anything on there. Might do yellow. Let's try red one. Nah. Nah. So not super for LEDs, which is a bit of a shame. It'd be nice with LEDs as well. Because if you're trying to do LED testing in circuit, like for example, because someone has got like an array of LEDs on it, you can go around and go test with this thing, you know, be really easy on each one, but you can't do everything, I suppose. So I thought let's try this voltage thing. Now I'm going to leave it in auto mode first to see if it detects the voltage in auto mode. So let's try low voltage first. Let's do like 10 millivolts. Nothing. Let's bring it up. Be nice to find out where it triggers it. There we go, detected it there. So, let's find that threshold. About 80 millivolts it detects as a voltage and switches over. So yeah, 80 millivolts it switches over to voltage. It's reading a bit out there though. So 100 millivolts, it's reading off by a fair bit actually. See, oh, there we go, it's getting closer there. The very low levels are quite far off. Yeah, below 200 millivolts it's quite far off, but it's getting closer. 700 is looking really good. 900 is looking really good. 1 volt. Just bang on. Actually, let's do bigger steps now. 2 volts. Bang on. 3 volts. Bang on. 4. Okay. 6. Bang on. 10. Very slightly off. Not much though. Back to 9. Might bring it upwards. I'm not sure where it rescales. Obviously it does change ranges, so 7's good. 8 is good. 9 is good. 10 is okay. I think unless I go too fast it changes ranges. But yeah, that's working. So if you need to do some basic voltage measurements, obviously limited by the scale, but in most cases that doesn't matter. That range on there, you know, if you're checking a 5 volt rail, it might be looking like say 5.1 volts or 5.2 volts. So the decimal places are plenty for that. You know, I've got 8.5 digit multimeters, you know, 7.5 digits and 8.5 digit multimeters and stuff lying around. So sometimes you need to do really precise stuff. This isn't for this. This is general purpose probing around, checking stuff. And in those situations, a 4.5 digit multimeter is perfectly fine. Hell, even a 3.5 digit, it will do the job most of the time. It's fine. But obviously, within the voltage limitations, what you can do. But it's actually nice, it does say when it's measuring voltages, that it's got that plus or minus 32 volts limit across the top of the screen to warn you, which is nice. So let's look at the scan feature. I've got a couple of capacitors out. We've all looked at it doing resistor. Let's look at it with the capacitor and see what changes. So the capacitor on there, see the steps through each one. So you can see the series resistance and the parallel resistance shown up there, as well as the Q. And so you can see how they actually compare there. And you can actually see that the series resistance is more obvious to see with a lower frequency, which is why it's good to measure with a 100 Hz level when you're doing electrolytic capacitors, because you can see if there's an error more easily with them. You see it's looking like 1.6 ohms there, series resistance, so ESR at 100 Hz. Let's do this one here, which is a 1000 microfarad. The other one's a 33 microfarad, I forgot to say. And this is a 35 volt. The other one was a 63 volt. You can see that the series resistance here has changed by quite a bit. Lower voltage and much higher capacitance. But again, you can see that the frequency has quite a big bearing on what you actually see. You know, you've got 45 milliohms to 9.5 milliohms between 100 Hz and 100 kilohertz. So that's like 4:1 ratio. It means if there's an error with the ESR, it's much easier to see it at low frequency. Anyway, that's something else. So now I put up my oscilloscope to this. We're going to look at the waveforms on the oscilloscope and see what we get. So I left it on the scan mode, and as you can see it's stepping through each frequency there. And you can see the frequency in the top right hand corner where it's stepping along. might be a bit of a delay there for the actual frequency it says, but yeah, so it says all the frequencies there, 100 Hz, 120 Hz, 1K, 10K, 100K. So you can see it there, and the amplitude there is about 1.8 volts peak to peak in that particular setup. And the actual levels are fairly consistent across each amplitude as well, so that's alright. So let's take it back out of that mode. Now we've got the waveform mode, as you can see there, and it says it's doing 100 Hz at 3 volts, and that is actually what we're getting. Though this frequency counter is giving me some glitching, which is interesting. So sine wave PWM, yep, that's there. Waveform was a bit interesting though, so look a closer look at this. Got some ripple noise, something here. It could be with my probing here. I could be picking up noise from my lights or something. It's entirely possible. Actually, yeah, when I let go of the body, when I'm holding the probe, like the metal body, it's getting the noise. Let go of it, it goes away. So that noise is from my environment being induced via me into the device. So can't do much about that. Triangle wave, all doing decent amplitudes. This is a trapezoid. Half wave. Again with me touching it, doing that, okay, and then full wave, yep. Since just the way it drifts around very slightly, but okay. Noise, yeah, well definitely is noise. It looks like a repeating pattern though, you can see the patterns are kind of repeating, so they're not actually completely random. And sine wave again. So, okay, get the accuracy, so 1 kilohertz. Yeah, it's not bad. Slightly off, but it's not bad. Well, I suppose the last thing to do now is to take the thing apart and have a look inside it. It's a machine screw. Okay. Not sure which way it comes out. Oops, push the button. Turn it back on again. Turn it back off. So we've got a 300 milliamp hour battery in there. What I don't like is the way it's sitting on top of the circuit board. If you've got something sharp on the circuit board there, it could actually be penetrating the battery. So you can see there's a little dimple just there for a start. Not sure what it's touching, but it's touching something. It's got a little bit of foam there, but I don't think it's really doing the job. You should probably put a bit more tape on that, to be honest. Anyway, there's the board. It's pretty small. Let's turn it over, get the parts right up. Yeah, T14A. Not sure what that is. So you can actually see now these are PCBs. These bits here. That's your circuit boards. Nice. So that is an optional component here which isn't installed. That looks like a programming header, potentially. For that controller, whatever that is. USB-C connection obviously, as we knew. I didn't mention that, did I? USB-C for charging. That's probably a charge control chip or something just there, I'm guessing. Okay, it's an artery device. It's an AT32F something there. So artery is what I've seen used in lots of these Zotek devices, so it seems to be their microcontroller of choice. So anyway, that all looks alright, doesn't it? It's all nice enough. Lovely. I mean, it all looks okay. I can't really see anything there of concern, apart from that battery sitting on that foam, kind of, which I'm not particularly pleased about the way it's sitting. You know, it just could use a bit more tape on it or something, like wrapped around some more. I mean, obviously this casing will do something, but if you got some Kapton tape here, could have just put some more over it, just to give another layer of protection. In fact, that's what I'm going to do. There you go, more Kapton tape around it. I call it Kapton tape because it's fake. But it's better than nothing. So we'll put it back together. and hopefully it still works. I mean, the construction looks really nice. The build quality looks good. Certainly one of the nicer ones I've got. In fact, mostly because it's aluminium. Aluminium, not aluminum.
Aluminium. Aluminium. Aluminium.
There's two eyes in the word aluminium. Turn it back on. Does it still work? Have I lost any dust inside the screen? Hey, it still turns on. Great. I think we're still in business. So thanks a lot, Zoyi/Zotek, for sending that to me at no cost. That's brilliant. Give me a thumbs up. So check out the links down below to purchase these things, or for more information on Zotek's website, firmware updates, that sort of stuff. It's all on their site. So check those links out down below. If you want to support my channel because you like what I'm doing, Patreon support link over there. Subscribe over here, or you can buy me a coffee. Catch you later.